In this lesson, we're going to talk about conditional probability. And this should be somewhat familiar to you because we have made contingency tables in the past. In this lesson, we're going to talk about a formula that we can use instead of making those tables. In our next video, then, we will put together conditional probability with the general multiplication rule. So remember, this is what that contingency table looked like before, that displays the results, in this case, of two categorical variables. And we're going to find probabilities to the nearest 10,000. So here we're going to just kind of do some practice because we've done this before. Keep in mind when we're dealing with contingencies, that means that our totals we might be using the total over here, any of those parts, as our total population, or we might be using any of these as our total population. So the probability of a girl means, obviously, out of all of them, girl. So there's 175 girls out of 357 total. So again, the probability would be me dividing those two and finding that as a decimal. Again, I'm going to always go to 4 places because it's a little bit more exact than 3. The probability of a freshman girl. Notice that I haven't used given yet, just a freshman girl. Well, there are 38 freshman girls out of 357 people. So again, I would just divide those two. Now, here's where we have to be careful. Given tells us that it is a conditional probability. So conditional means based on a condition. So this is saying the probability of a freshman given it's a girl. Now, given it's a girl means that my denominator is going to be 175. So it's given that it's a girl. How many of those are freshmen? Well, obviously that's 38 out of 175 instead of 38 out of 357. So given it's a girl tells me that's the denominator. Probability of girl given it's a freshman, again, now my population is all of the freshmen. So it's freshman girl over the 82, which is total freshmen. So girl given it's a freshman. So again, notice the difference between all these. These are all girl, freshman girl, and then these are my conditionals. So these are just our normal probabilities. Now, we just did these questions on the other page, but now I want to show you what happens when we use the actual conditional probability formula. So conditional probability formula, you should know this, learn it, understand it, love it. So what this means is the probability of B given A. Probability of B given A means find the probability that B occurs given that A has already occurred. So what I'm going to do then is find the probability of both B and A over the probability of A, because just like before, that probability of A is my denominator. The probability of the given is my denominator. Now, again, I wouldn't probably use that in this case because I've got all of the numbers in front of me, but I want to show you on this example how we'll get the same answer so that on our next example where we have no table, hopefully it will make a little more sense. So the probability of a freshman given it's a girl means on the top, I'm going to put the probability of both a girl and a freshman, and on the bottom, I'm going to put the probability of A, which is girl. So look what this looks like. I've got 38 out of 357, which is the probability of a freshman girl out of 357. Here, I've got the probability of a girl, which is 75 over 357. Well, what's going to happen with those 357s? Essentially, they're canceling out because I've got 38 divided by 357 if I multiplied by the reciprocal. So 38 over 357 dividing by a fraction means multiply by the reciprocal, 357 over 175. And notice what I get, 38 out of 175, which is exactly what I had last time, which is exactly the same decimal. So again, would I use it in this particular circumstance? No, because I've got all these numbers right in front of me. Let's look at the second one, girl given freshman. Again, the numerator would be girl that is a freshman, so that it's in both categories, 38 out of 357. Given freshman means that it's 82 out of 357. The same things would happen with the 357s, and I would get the same answer. So let's take a look at one where we don't have the numbers in front of us, where it's actually impossible to figure out without using this particular formula. So if 33% of students at Bellevue University are in relationships, 25% are in sports, and 11% are in both, find the probability that a student athlete you see is in a relationship. Well, it's important to understand which one is given here. Find the probability that a student athlete that you see is in a relationship means find the probability of relationship given that it's an athlete. So it's important to know which is which, because if you put these in the wrong order, then obviously you're going to get the wrong solution. So the probability of relationship given student athlete would tell me the probability of athletes that are in a relationship, so the probability that it's both of these things, both relationship and student athlete, over the probability of the given, the athlete. In this case, that would be the 11% are in a relationship and an athlete, over the 0.25, which is 25% that are in sports, so the athletes. Notice that gives me 0.44. That says there's a 0.44 probability, or 44% chance, that the student involved in sports is in a relationship. To me, the hardest part is coming up with this one, so just make sure you take your time to figure out which one is the given. Note, and we'll talk more about this later, this is higher than the probability that any student is in a relationship. So in general, students in relationships are the 33%. In athletes, it's 44%, okay, which will lead us into our discussion on independence. Before we talk about independence, let's give you a chance to try one of these on your own. Press pause, try all of the questions. I do want to point out before I set you loose to do these on your own that I have not given you totals here or here. So it's important to understand that these are just your 4 data pieces, and I didn't give you any totals, but that's okay. You should be able to figure it out without the totals. So press pause, try all 4 questions, then press play to check your work. So the first one we're dealing with cholesterol and high blood pressure. So the first thing I want to know is what's the probability that a subject has both conditions? Well, both conditions, of course, would imply not that they have okay cholesterol or okay blood pressure, but that both are high. So that would, of course, be the 0.11. That's high cholesterol, high blood pressure. That's where those meet. What's the probability that a subject has high blood pressure? Well, high blood pressure would be anybody in this column. So those are people with high cholesterol that have high blood pressure, and people with okay cholesterol that have high blood pressure. So I would just add those together. And again, if I had that total column already, I wouldn't have had to do any math. I would have just said the answer. But because the total wasn't there, I had to add them together. Next, the probability a subject has high cholesterol given. So now this is where we have to be careful. Given that she has high blood pressure, he or she. So that means it's the probability of high cholesterol given the high BP. Now, please remember that whenever we do a question like this, that the top number, the numerator, is all of the people that are in both of those categories. So who has high cholesterol and high blood pressure? That's these people. High cholesterol, high blood pressure, 0.11. The denominator is just this. Who has high blood pressure? Well, that's all of these people, the 0.27. So it's everybody essentially in that column. And notice now, just as we did before, 0.11 over 0.27 gives me 0.4074. And the last one, the probability a subject has high blood pressure given high cholesterol. So now we're going the opposite direction. Keep in mind, though, that this top number should stay the same, because the top number is people who have high both. And the bottom number, instead of 0.27, will be given the high cholesterol would be anybody with high cholesterol, which would be this total column, which would be 0.32. So anybody with high cholesterol is 0.32. That should be our new denominator, which gives me my total of 0.3438. I wanted to add one more practice question to conditional probability, because you do have questions like this in my stat lab and they can be a little bit confusing. So first, I've got essentially a conditional probability table, and what's different about this table is that they're not going to give me all of the values on the inside, so I'm going to have to do some math essentially, to figure it out. Now, because it's a probability table instead of just a conditional contingency table, I know that the total is 1.00, or just 100% essentially. So that's going to be one thing I know right off the bat. Now, other things they tell me are that we have 72% of users outside the US, 58% of the users log in every day, and 19% are both in the country and log in every day. So we're going to make the probability table sort of in reverse. So on the first one, I can put in the values that I'm given. So I'm given that 19% of its users are from the country and log in every day. That's 0.19. I'm given that 72% are from outside of the US, or the country, I guess I'm assuming US, so that's 0.72 here. And then I'm given that 58% of its users log in every day. So here are the three that I'm given. Now, from here, I'm going to have to do some math to figure out the other values. And so one thing I can do is I know that the total is 1, which means the total in this column is 1 and the total in this row is 1. So then I can, of course, just subtract from 1 to find the missing result. So this would be 0.42, which I subtracted 0.58 from 1. This would be 0.28 because I subtracted 0.72 from 1. Now from here, I should be able to figure out the rest of the values. So I should be able to figure out this value, because if I take a total of 0.28 minus 0.19, that's going to be the value here. If I take 0.58 minus 0.19, that would be the value here. And then of course this one would be found in the same way, either using the value that I come up with here or the value here. So then I can of course just work backwards. So the 0.39 was 0.58 minus 0.19. The 0.09 was 0.28 minus 0.19, and then this one I could find either this direction or this direction. So I wanted to throw this one in here just in case you got confused on making the probability table yourself.